So under the analytical tools, the third one, logical data modeling. So let's write down logical data modeling. We are not going to actually talk about this in detail, but once we look at databases, we look at entity relationship diagram, there I will visit again. So briefly, we'll write down what this means. Right. Let's write down. Logical means we can identify the details, logical details, meaning before we actually going to create this, we can create the logic diagram, right? We have to identify some of the things. So let's write down. Let's write down under this. A logical data model uh, is used to define the structure, data elements, and the relationships among them. It consists of logical data structures and associated descriptions. Components, entities, their relationships, their degree of you can say optionality of a relationship. The details I'll come and talk about you later. Okay. Last one under 7.6 business system options or BPO. We call BPO. We can write down BPO describes what the system will do. BPO describes what system will do. So each BPO should satisfy each BPO should satisfy Right. So BPO means business system options. You go into more details. What approximately how much cost involved in this, and this is relevant for all the systems. Right. So that's 7.6. Right. Let's move to 7.7. We are going to look at the designs, the proposed system. We will look at what logical system is, logical design stages, and all this information we are going to keep it there. Right. So the databases, since we are going to talk about the database, I'm going to talk about these details in detail there. But we need to look at how we plan the system and then how we can test. Let's write down design the proposed system. This is 7.7. Right. Under this, I'm going to look at the very first thing I'm going to discuss logical design tools. Right. Under that, I'm going to talk about the first thing. What is the first thing? Logical data flow modeling. Data flow modeling. We call logical data flow modeling. Right. Right, under that we will write down physical data flow model shows how data is actually processed and data is where the data is actually stored in the system. This is logical flow modeling. Then logical data flow modeling shows how data should be processed and where the data should be stored in the proposed system. Finally, we can say from the same thing, we can say logical DFM consists of set of data flow diagrams and associated text descriptions. Right, so that's logical data flow modeling. Right, then the second one we'll write down logical data modeling, LDM. So this one adds new entities are required to support any new functionalities provide logical data stores, entities identified in the LDM for logical data flow modeling. Remove any temporary data store that simply holds data temporarily. පුතේ මේ අන්තිමට ක්ලියර් ඉවරද?
නෑ සර් තාම ලියන.
උඩ ලියලා ඉවරද මේ ටික?
ඔව් සර්.
right හරි. පුතේ චූටි බ්‍රේක් එකක් ගමු මම කෑමට යන්න 10 minutes වලින් වගේ අයලොග් එකක් මම මෙසේජ් එකක් දාන්නම් පුතාට.
හරි සර්.
Miss you. Physical database design, you design the database, which means the entities, attributes, instances converted into tables. We know in a database what we have tables. Then we discuss something called normalization, which we discuss later on. The normalization should be done up to third normal form. 3NF means third normal form. And it should give us a physical design, which means a code to create the database. Then the next thing that we need to discuss is the data dictionary, which means the data about data, right? When you store data in a database, we need to keep track of information about data. For example, let's say I'm going to store data about a person name. Right? When you say person name, how you are going to store? Are you going to store as a string? Then secondly, you have to decide how many characters you are going to store and so on. Right? Develop development of the system and testing. Right. Mainly in this part, we are focused mainly on what testing is, right? And under that, I will show you now things like test cases, right? And different types of testing available. Now, if you remember earlier, we discussed unit testing, integrated system testing, exception testing. But before that, we are going to add two more this type, white box testing and black box testing. So these are the things that I'm going to cover here. Right. Okay. Let's write down about the testing first. The proposed system should be checked for any errors, right? It uses manual and automated tools to evaluate the functionality of the system or feature, right? So that is testing. So whenever you develop a system, we need to check for any errors. Right. Now under this, we'll first talk about something called test cases. Let's write down. A test case is a set of actions to verify a particular feature function in the developed software. So we are going to check something. Now, this includes specific variable or conditions. Which can be compared with expected and actual values. Right, we can check something. Test cases are written so that, we can check. So it's called test cases. Test cases are documented by the quality assurance team, right? So that's about the test cases. I'm not going to go into details. Right, now I'm going to look at some software testing techniques. Look at some software testing, yes, techniques. Software testing techniques. Right. We have to discuss couple of testing. So I'll start from the beginning. First of all, white box testing. So the first one we are going to discuss is called white box testing. So white box testing means you look at what is inside, you check inside. We can say internal implementation. Sorry. So usually this is done in the very early stage of development of the software. Then we will also have done right black box. This is opposite. Now, in previous one, we look at the internal information or what is inside. But black box means it is outside. You look only for inputs and outputs. You look for only inputs and outputs. So that is called black box texting. Right. So let's write it down. Testing checks on internal implementation of a software. This is checked in early stages of the software development. So this happens in usually early stage. White box testing. Right. So in black box testing, on the other hand, checks only the input and output. You just check input and output only. That's all. It is what we call black box testing. සල්ලියකට ඉවර නම් කියන්න. So the next part, we will look at software testing types. So when I say software testing types, I'm going to look at a couple of things. And usually we can look at a few things, what happens in the kind of start to finish. Right. The first thing that I'm going to discuss under this, we'll start with the unit testing, which we have discussed earlier, but in detail. Right. So usually we have unit testing, right? We have unit testing. We will have process for this. We can have unit testing. Then we will have system testing. Sorry, integration. Then we will have system testing. And finally, we have acceptance testing. So we will have a hierarchy like this. Right. So these are the 4 different testing types in a software, right? Now, when you say a software system, you have subsystem, you have parts of it. And the subsystem we create using individual programs like functions or classes. Unit testing starts with test individual program units. And by programmers and white box testing is used. Then we will have integration testing. Integrate the individual program units and test them, right? Again, done by integrate testers or test teams. White box or black box can be used. So that is integrated testing. Next, system testing. Test the whole system as a single unit. Done by test teams. Black box testing is used. Finally, acceptance testing. Users will check the system. Users check the system. That means this is called acceptance testing. Right. Okay. Now I think we left with only one part, 7.9 and 7.10, which is we have already done earlier.